What is gene drive? UCI-MI has developed a modified mosquito that contains beneficial genes and a gene drive. The modified mosquito has the same DNA as the mosquitoes in the natural population, plus the beneficial genes which have been added to the DNA. These genes prevent malaria parasites from developing inside the mosquito so that it cannot transmit malaria to humans. Gene drive is a tool that has a special ability, which allows specific genes, like the beneficial genes, to become more dominant in a population. To understand gene drive, we must first understand what genes are. A gene is a unit of specific information that an organism inherits from their parents. An organism has two copies of each gene. One is inherited from the mother, and the other from the father. Normally, a gene is inherited 1/2 or 50% of the time from one parent and 1/2 or 50% of the time from the other parent. When a modified mosquito mates with a mosquito from the natural population, we would expect the beneficial genes to be inherited by 1/2 of the offspring. This is known as normal inheritance. This means that some of the mosquitoes will be incapable of transmitting malaria. But because mosquitoes that have the beneficial genes often mate with mosquitoes that do not, that number will decrease over time. If we want all the malaria-transmitting mosquitoes to carry beneficial genes, we need to increase the rate of inheritance of these genes. Gene drive is the tool for this job. It is used to drive the beneficial genes from the parent to nearly all of the offspring. A gene drive is coupled directly to the beneficial genes in the modified mosquito, so that the gene drive and beneficial genes are always inherited together. When a UCI-MI modified mosquito with gene drive mates with a mosquito from the natural population, the offspring will inherit a copy of the beneficial gene from the modified mosquito parent. The gene drive will find the matching DNA sequence, or target site, on the DNA inherited from the mosquito parent from the natural population. When the gene drive locates the target DNA sequence where beneficial genes should be added, it will cut that specific area on the DNA sequence and insert a copy of the beneficial genes. As a result, the offspring will carry two copies of the beneficial genes instead of one. No genes are deleted. Now, when the offspring of the modified mosquitoes mate, the entire process is repeated. Gene drive ensures that all offspring of the UCI-MI modified mosquitoes, after several generations, will carry the beneficial genes, modifying the mosquito populations. Thanks to gene drive, mosquitoes can be modified to prevent malaria transmission and contribute to the goal of malaria elimination.